use completing the square to find the minimum point for this curve. Right, this is a quadratic equation, and what's not going to be given to you for this type of question is the graph of this. Now I'm just going to show you the graph. It's already plotted. It's right here. Now the minimum point it's referring to, I'll show you, it's right here. There's the minimum point. It's 3 along the corridor, -8 down the stairs. Right. So the 3 refers to the x value, the -8 refers to the y coordinate. Right. But I need to show that this is the minimum point. I need to find the minimum point using algebra, using completing the square. So I need to complete the square for this. So I'm going to complete the square for this. It's a quadratic. So the first thing I do is I open up the brackets like this. I create the brackets like this with the square. I need to have the x. So that's how I start off with for completing the square. Now looking at the middle number, that one there, half of the -6, half of -6 is -3. So that's the second step. So then what do I do with this -3? Well, I do -3 squared, -3 squared, -3 times -3 is 9. So I take away that 9. So you can see where that 9 came from. And don't forget, there's a +1 at the end. So I need to put that on. So let me just simplify that now. That's x -3 squared, -9 add 1 is -8. Now, I've just told you this, right? This one here, it's plotted over here, and its minimum value is right there. Right, this one here, this thing over here, is plotted already. It's the same graph. It's the same one. It's this one. Because if you think about it, this is the completed square version of this quadratic expression. This is the completed square version of this quadratic expression, and what's already plotted is a quadratic graph. So this one here, since these two things that I've circled are identical, they just look different, but the same thing, referring to the same thing, they're referring to the same graph. You can see from the graph the minimum point is -8. Now, how do I know? If I didn't have this graph, then how would I tell? How could I do it? Just by inspecting this completed square version. What would I do? Right, I would have to think, what value of x can I put in there? What value can I put into this x? What value can I put into the x to give me the smallest possible value of y? Well, if I replace x with 3, if I replace this x with 3, which is exactly the opposite of -3, so if I put that in there, let's see what happens now. 3 take away 3 is 0. 0 squared is obviously 0, so all of that is 0. Then you got the take away 8. 0 take away 8 gives you -8. So the y value is -8. That is the minimum value. So if I have another example, just a quick example, let's suppose I got something like this. Right, the minimum value would be, well, x is equal to, x would be 2. X would be 2, the opposite of -2. And the y value would just be 5. Right, another one. Let's do it quickly, another one. Let's suppose you got this one. Right, in this case, the x value would be opposite of +3. Opposite of +3 is -3, and the y value would be just that -7 there. Right, another name for this is called a turning point. The minimum point, maximum point. Right, if it's a maximum point, the graph would be the other way. Right, that would be the maximum point. what we refer to as turning point, is where the gradient, as you can see here, as we're going down, the gradient is negative, still negative. At this point here, the gradient is 0, and then it becomes positive. That we call the turning point. Just by looking at the quadratic equation, you cannot determine the minimum point, maximum point, the turning point. You can't determine that. But by doing the completed square version of that quadratic equation, you can find the minimum and maximum just by inspecting